3 times in human history we've spotted something in our skies that didn't come from our solar system. First was Oumuamua, then came Borisov. Now scientists are buzzing over a brand new discovery, 3I/ATLAS. It's flying toward our sun right now at nearly 60 kilometers per second, and it's unlike any comet astronomers have ever seen. But what exactly makes this object so unusual, and why are so many telescopes across the world scrambling to watch it every single night? Before we jump in, I have a quick favor to ask. We're just getting started, and your support really helps us grow. So if you're enjoying this, please hit the like button and subscribe. Thanks so much, and now let's dive into today's mystery. Just picture a comet that is so swift that not even the gravitational pull of the sun can stop it. Why would you be able to say with absolute certainty that it did not originate from our solar system? During the initial discovery of 3I/ATLAS in July of 2025, this was the conundrum that astronomers were confronted with. The course that it took indicated something very different, despite the fact that it appeared to be a brand new comet at first view. Its path was stretched out into an open hyperbola, rather than following the elegant oval curves that are typical of comets. A hyperbolic path is analogous to a cosmic flyby in that an object enters, revolves around, and then disappears forever, without ever returning to its original position. That was the first indication that this was not at our sun's local level. Consider how the majority of comets behave in order to comprehend the significance of this. They spend a great number of years going to locations that are far away from the planets, like as the Oort cloud, before they finally come back to Earth. First they get illuminated, then they develop tails, and finally, after passing the sun, they begin the cycle all over again. In order to maintain their connection to the solar system, their orbits are ellipses, which are closed loops. Even long-period comets, which can take millions of years to return, will eventually return to their original orbit. However, with the help of 3I/ATLAS, researchers were able to immediately assess something peculiar: its eccentricity. A stretched orbit can be determined by looking at the eccentricity. The value of a perfect circle is 0, while the majority of comet orbits are quite close to being equal to 1. In contrast, 3I/ATLAS had a score of 6.14, which is quite high. Due to the fact that it is such a little number, it is not even remotely possible for it to belong here. The speed of it adds even another layer of convincing evidence. Astronomers estimated that it was traveling at a speed of between 58 and 61 kilometers per second as it approached. To put that into perspective, even the most spectacular long-period comets hurtle inward at considerably slower speeds and continue to be bound to the embrace of the sun. No matter how strong the gravity of the sun is, the momentum of 3I/ATLAS would prevent it from being slowed down or steered into an orbit that would allow it to return. It had an excessive amount of raw energy, more than enough to ensure that it would travel through our skies in just one direction. The direction of travel was even stranger. Instead of moving in the same general direction as the planets, it approached on a retrograde orbit, almost completely opposite at around 175 degrees to the plane of our solar system. Imagine the planets all streaming around a racetrack one way, and then picture a lone runner heading nearly the exact opposite way, crashing through the flow. That is what 3I/ATLAS is doing. It cuts across the planetary dance at an angle that no object from our system should take, another unmistakable clue that its birthplace lies elsewhere. All of this added up quickly. Within days of early observations, researchers realized this wasn't a rogue comet thrown off course from Jupiter's gravity, or some bizarre long-period comet making its first appearance. Its eccentricity, its outrageous inbound speed, and its completely off-track orbit combined into a clear picture. This was an interstellar visitor, an object forged near some distant star, wandering space for untold ages before arriving here. The sun could no more capture it than you could catch a bullet by holding out your hand. For astronomers, that certainty was exhilarating. The data left no room for doubt. 3I/ATLAS was only the third object we've ever caught passing through from the wider galaxy. Unlike the countless comets we see circling the sun, this one's trajectory proved without question that its story began in another star system. The riddle was solved, but that was only the start. Because the real surprise about this stranger isn't just about where it came from. It's in what it's made of, and that's where the mystery deepens. The appearance and behaviour of an interstellar comet might be similar to that of the comets that we are already familiar with, displaying a mixture of ice and dust that has been liberated by the heat of the sun. Those instructions were not followed by 3I/ATLAS. The first time that astronomers pointed their telescopes at it, the photographs revealed a brilliant coma that was so bright that it obscured the true core of the comet. The challenge consisted of determining the size of the nucleus that was in the background. Certain preliminary simulations suggested that it might be as little as half a kilometre in size. There were many who believed that it could span a distance of 10 kilometres. The fact that the coma obstructed the view and made it difficult to determine its actual magnitude led to the wide range of predictions. When contrasted with the two interstellar visitors that we had previously encountered, this ambiguity was immediately noticeable. Oumuamua, the first, never displayed any signs of being in a coma. More than anything else, it appeared to be a naked shard of rock that was quietly slicing through the solar system. The second one, Borisov, appeared to be practically identical to a textbook comet. It was full of gas and dust, but it didn't have any peculiar chemistry. It was just going at an impossible speed. The 3I/ATLAS spacecraft appears to be in the middle of these cases, exhibiting a bright atmosphere of gas, but also emitting signals that did not correspond to what scientists believed they were observing. It was the composition of that blazing cloak that was the source of the surprise. In a typical scenario, water vapor is the gas that drives the activity of comets as they are heating up close to the sun. From the hundreds of comets that have been observed in the solar system, we have learned that the tail and coma are fueled by the transformation of frozen water into steam. Those patterns were broken by 3I/ATLAS. Researchers were able to determine that carbon dioxide was the predominant gas by using the spectrograph that was attached to the James Webb Space Telescope. In addition to being present, it is overwhelming. This comet had a ratio of carbon dioxide to water vapor that was higher than any other comet that has ever been measured. The finding was supported by multiple other instruments. Those chemical ratios were revised through observations made by the Very Large Telescope, and the SPHEREX mission validated the values across a variety of wavelengths. All of them showed that the amount of carbon dioxide that was leaking out of the surface was astonishing, while the amount of water that was supposed to be released was significantly behind. To have a better grasp on how peculiar this is, you might think about it in terms of behavioural patterns. Consider a normal comet to be analogous to a tea kettle that has been placed on a stovetop that is extremely hot. The tea kettle hisses and steams and boils water. 3I/ATLAS has a non-standard behaviour. Imagine if instead of steam, jets of dry ice are venting directly into space. This would result in a significantly smaller amount of water vapour being released than you may expect. The catalogue of chemicals did not end with carbon dioxide. Signals of carbonyl sulfide, carbon monoxide, and even metals like nickel were detected during the analysis for the first time. There are comets in the solar system that contain these elements, but they are rarely seen together in such high concentrations. Their presence provides evidence that a cometary nursery existed, in which ices froze under conditions that were far different from those that prevailed close to our Sun. Chemistry that is formed under a disk that is either cooler or richer in carbon might readily explain why carbon dioxide is the dominant component of the composition, rather than water. Each and every one of these molecules functions as a kind of seal of approval. The comet is identified as the result of a disk that formed around another star billions of years ago, according to these findings. In the event that water was the predominant component of our comets due to the equilibrium that existed in our early nebula, then an object such as 3I/ATLAS would indicate that its home system followed a different formula, hence storing more carbon-rich components. Due to the fact that it provides a frozen sample that has been unaltered throughout interstellar space, the composition is extremely useful because it is currently venting into our sensors. It is not just the coma or the speed of 3I/ATLAS that sets it different from other systems. It is the chemical signature of the gas that is being talked about. The exceptional ratio of carbon dioxide to water is the most convincing indication that we are looking at stuff that has been preserved from the environment in which another star was born. Every molecule that escapes is a reflection of decisions that were taken in a disk that is billions of years away and light years away. If 3I/ATLAS is successful in rewriting what we believe comets are capable of carrying, the next issue that scientists are hoping to find answers to is what new information about the galaxy these interstellar messengers might bring with them. 3I/ATLAS is a reminder that our solar system is not sealed off. Between the quiet orbits of planets and moons, fragments from other stars pass through, carrying records of environments we cannot reach. Even if this comet never comes close to Earth, its chemistry and trajectory give us direct evidence of how different planetary systems can be, as every observation is like borrowing a sample from another corner of the galaxy without leaving home. And if this is only the third one we have caught, how many others are already on the way, waiting to be recognized? That's it for today's episode. Thanks so much for watching. If you enjoyed it, don't forget to hit that like button and subscribe so you don't miss what's coming next. We've got plenty more mysteries to uncover together. See you in the next one.